Hello, this is Nikolaos Vandoros, and I will be presenting assignment 2, which I conducted with Dimitrios Tsimpoukis. We are not at the same cities at the moment, so I will be presenting the k-means clustering, and he will be presenting the k-nearest neighbor algorithm. We begin our assignment by by giving the JDBC driver name and database URL, and then by asking the user to provide their username, their SQL Server username and password, and then to input the name of the database. We need those databases because this is where we're gonna get all our values and measurements from. This is gonna happen through those two classes. We have the measurements class, which we will use to extract the name the data from the measurement and the analog values table, and each of those tables have the RDF ID of the measurement, and then the name, which is the substation underscore voltage or angle, and then the substation RDF ID from which the measurement was taken from, and then the time at which the measurement was taken from, and the value of the voltage or angle. Similarly to that, the substation table includes a column of RDF IDs, a name of the substation, and then the name of the region of the substations, which we first read and then we return to our main program. We have three array lists that we will use further in the program, and which we initialize and fill through the database. That we do through methods. I will present the getMeasure method, and then the other two methods are pretty much similar. So the getMeasure method goes on and initiates the connection with the database, and then after we use the database, we select everything from that from the table measurements of the database. We assume that the table names in the database are still measurements, substation, and analog values. We can change that. It's easy if you want us to. And then, to make our life easier, we go on and order the measurements by time intervals. And then we get columns, we get rows 0 to 10,000. In our case, it's 0 to 360. We put up to 10,000. We can make it even more if you want us to. That's easy here. And then we go on and get an object of the class measurement that has inside the values for respective columns, and we add it to an array list called MEAS list. That happens as long as our database has more rows. Then we close the connection and return the array list to our main program, and this is what we will work with. The first thing, we assumed that we figured out that the database that you provided for us provides time intervals going from 0 to 100, from 1 to 200, with no intervals in between. So we have the measurement for time 1, time 2, time 3, time 4, and then until 200. If you wanted us to make a more general case for different intervals, maybe you want us to have a measurement for time 1 and then time 5 with no measurements for times 2, 3, and 4. We can do that. But we utilized what you gave us because it made our life easier. We also figured out that the measurements were provided in ordered by the name of the substation. So we have first the measurements for substation 1, then the measurements for substation 2 up until 9. We can change that as well and make a more general case if you want us to, but it still made our life much easier. We created an array list containing all the time intervals at which measurements were conducted. This is pretty much easy because you can go on the measurement array list and then get the indicator and divide it by 18, in our case, 2 times 9 substations. And if the module is 0, then you have the time at which its measurement occurred. Then we created a table, an array which included all the lines of the system. This system is the one that you provided. It has lines 1, 4, 2 to 8, 3 to 6, up until 8 to 9. And then what we did is we went on and started our KNN clustering. And we first initialized our clusters. Cluster 1 was set to be the high load case, cluster 2 the low load case, cluster 3 the disconnected line for a maintenance case, and cluster 4 the disconnected generator. In order to find out when our clusters were initialized, we set an unrealistic value for the voltage of substation 1 in its case, which is -1. Of course, this cannot be the case. And then we went on the measurement table and calculated the voltage drop over each line of the system. This is done pretty much easily here. This method returns the voltage value, the absolute value of the voltage drop on the line. So what we did is we went on and tried and checked the 3 first lines. These first 3 lines are 1 to 4, 2 to 8, and 3 to 6. These are the lines that connect our generators to the main system. And we figured that if this is more thoroughly described in the document that we provided with these videos, but we figured out that if the voltage drop is too low on those lines, then we have a disconnected generator. We set too low to be 10 in the -3. If this is the case, then we initialize this cluster and then we stop and go on to the next. We go on to the next measurement. If this is not the case, then we check the voltage drop on every line of the system. And if this is too high, we set it to be 0.28. We figured out that this is the case where we have a disconnected line. If none of those 2 cases are fulfilled, then we go on and check the voltage on the load buses. And if the voltage on those load buses is low, then we have a high loading case. If it isn't, then we have a low loading case. And this is how we initialized our clusters. After that, we went on and did the k-means clustering. We have an array list for each of the clusters containing the time measurements that belongs in each cluster every time we go through the measurement table. Then we have an array list stating that its measurement belongs to some cluster. This will come pretty handy. We initialize this array list and then we start our clustering. We go on and calculate the Euclidean distance between each measurement and each cluster. And then we go on and check which is the smallest of those distances. If the smallest of those distances is distance 1, then we cluster this measurement to cluster 1. And we check whether this measurement already belonged in this cluster. If it did, then we have this flag to be false. If it didn't, then we set it to belong to this cluster in the C belongs. That's the same thing for everyone on one of those. Excuse me. Then we go on and sum and create a sum of all the voltage and of all the voltages and then of the angles of every substation for every measurement that belonged in each cluster at the time we went through the table. And then we find an average of those. And if no measurement moved clusters, then we are done with clustering. If it did, then we go on and calculate the distance to our new clusters, which are the average clusters. And then here we have some outputs. These outputs are not actual outputs of the program, but we will just run it so you can see how this part works a bit. So I input my SQL Server username, my password, and then the name of the database with subtables. And as you can see, 49 out of 200 measurements belong in cluster 1, which is the high load case. 51 measurements belong in cluster 2, in the low loading case overnight. And then 47 measurements belong in cluster 3, which is the cluster that indicates that we have maintenance of a line. And then 53 measurements belong in cluster 4, which indicate the disconnection for maintenance of a generator. And then Dimitrios will go on and present the KNN, the K nearest neighbor algorithm. Thank you. Bye.